Welcome back to the OpenVINO channel. We've talked about the full video analytic pipeline in previous videos. The first stage in the pipeline is to uncompress or decode the input video stream. Please check out video 54. This is a very compute and memory demanding operation, especially if you're dealing with high definition videos in high frame rates, or you're trying to process many video streams coming from multiple cameras or feeds concurrently. Intel QuickSync technology uses the fixed function in the integrated GPU I call VDBox and VEBox to accelerate video decode, encode, and processing. As I mentioned in previous videos, you will need to make sure the driver is installed, and if you have OpenVINO working on the GPU, you're all set. If not, check video 18. You will also have to make sure you have the right GSTREAMER version and VA API. We'll see that. In this video, I'm going to take a simple Python sample code and just change a line or two to move the decode from the CPU to the GPU. I'll show it in 3 stages. Number 1, we'll get the sample code, all the collaterals, and we'll just operate it on the CPU. Number 2, we'll run the same sample code, but we will use GSTREAMER to make sure the decode is executed on the GPU. And number 3, we will run the same sample but use Media-SDK for the decode, again to execute on the GPU. Part number 1, I'll build a new directory, accelerate decode. I'll go to the model downloader directory and let's try to download MobileNet SSD and place the model in my directory. And I'm getting the prototext and the cafe model. Now we need to see if there are any special conversion parameters. I'm looking for MobileNet SSD, and yes, we need to scale and apply mean to the values. Let's run the model optimizer for cafe. My input file is the cafe model. I want the output to be placed in my directory, and I'll add the scaling and the mean factor. And I have an IR file, an XML and bin file. Let's go back to our directory. Now I need to bring the Python sample. I'm using the object detection using SSD async sample from inference engine /demos/Python demos. Now let's copy a video file. As I explained in video 54, MP4 is a container. Media-SDK needs a native video stream in H.264. So we'll use FFmpeg to generate this video file. This simple command line will take our video1.mp4 and convert it to video1.h264. That's all. And we have the 2 files. You can see that I can play both with VLC. They look the same. So we are all set. We have the model, we have the sample code, and we have 2 input video files. Let's open a metrics monitor to gauge the utilization of the GPU. This utility is part of the Media-SDK samples. Please take a look at video 45 for explanation. I'll need sudo permissions, go to the samples executable directory, set up all these environment parameters. You can copy and paste them from the transcript. And here are all the Media-SDK samples. Let's run the metrics monitor. You can see here the utilization of the execution units. Here is the decode acceleration, and the GPU is hardly working at about 300 megahertz. Now let's run the sample code. Input is my MP4 video, model is MobileNet SSD, and it's working. As you can see, the decode is running on the CPU and the GPU decode is idle. Now let's use GSTREAMER for encoding. I'll create a new version of the sample code and I'll call it GST underscore object detection, etc. Let's edit this code. On line 108, you can see the OpenCV video capture function. We will replace it with this line. This is basically a GSTREAMER pipeline. Here is the video file to open. We want to decode it, convert it, and so on. This line is all it takes. We do need to make sure that GSTREAMER is set up properly. The result of VA info should look like that. Driver should be i965, VAPI version 1.5. Let's also check GST inspect, and the result should look like that. Now let's run the modified sample with the same parameters. You can see that the sample is running and the decode is running on the GPU, just like we wanted. If for some reason you do not have the same environment that I have, try to unset the following environment parameters. Next thing to do is use Media-SDK. I'll create a new version of the sample code. I'll call it MSDK underscore object detection and so on. Let's edit the sample. On line 108, you can see the OpenCV video capture function. Let's change it to this line. I'm giving the path to the video. Please note that this is a H.264 video. Media-SDK cannot process containers like MP4. Handling all the parameters is also a little different, so we'll need to change these two lines to get the height and width from the frame. And that's all. Let's make sure the environment setting for Media-SDK is okay. VA info should give you something like that. Driver is IHD, VAPI is 1.4, and let's run it. And it is working. And the decode is running on the GPU, just like we wanted. Great. So with just replacing one line of code, you can move your decode from the CPU to the GPU, do it more efficiently, and hopefully be able to process more video streams in parallel. I have demonstrated here for OpenCV in Python, but you could do the same for C++. Feel free to ask questions in the forum and check out the documentation in the link. Thank you.